In this problem, we've been given the null hypothesis that pi is equal to 0.4, the alternative hypothesis that pi is less than 0.4. The sample size is n equals 50. I do 100 repetitions in a simulator, and it tells me my sample statistic is p hat equals 15 out of 50, which is 0.3. And I give you a picture here of the actual simulation that I did with the Rossmann chance applet. Part F asks us to describe how to make the computer simulator find this p-value, and then we're going to go to the computer simulator and do it. Now, when we actually go to the computer simulator, we have to realize that every time we do a simulation, all of our simulations will come out a little bit different. And so when you try this at home on your computer, and I try it here in a moment, our distribution is going to look slightly different than the given distribution here from when I use the simulator another day. And yours will look a little different, and mine's going to look a little different. And that means your p-value will be a little different than mine, and my p-value will be a little bit different than the 15 out of 100. However, your p-value that you get when you do the simulation and the p-value I'm about to get will be similar to 0.15. I will still get a big p-value that leads me to the same conclusion overall about the null hypothesis. That the null hypothesis is plausible. I expect that you're going to get a p-value somewhere between 0.1 and 0.2, around there. So let's give it a try. All right, I go to the Rossmann chance applets. I open up the one proportion inference app. Okay, so our probability of heads. In here, we enter the value from the null hypothesis, which was 0.4. The number of tosses, our sample size, was 50. We're going to do 100 samples so that we see 100 simulated dots here. And I'm going to go ahead and hit draw samples. There it is. Notice it's still centered around 20. It looks a little different than the one that I had in the lecture guide, but it's very similar. If I switch to proportion of successes, it will be centered around 0.4. Yes, so you see it's around 0.4 in the middle. All right. How do you actually go about finding the p-value here with the simulator? Remember, we want the computer to come here and locate 15, which was our observed statistic. Our observed statistic was 15 out of 50. So we want it to locate that and count the samples that are like that and lower. And to do that, you're going to use this area here, the as extreme as count area. So the first thing you want to do is you want to come here into the little box and you want to put in your observed sample statistic. Be very careful. If you're on number of successes, I would enter 15. But if you're on proportion of successes, you would have to enter 0.3 because 15 out of 50 is 0.3. You need to make sure you're really clearly aware of which button you have pressed and that you put the correct count in here for your sample statistic. So I'm going to just go ahead and put it on number of successes, and I'm going to put in 15. We saw 15 successes in our observed sample statistic. The next thing you got to do is you need to select this box to match up with your alternative hypothesis. My alternative hypothesis was a less than symbol. Pi is less than 0.4. Notice, if I have it on less than, it turns all the dots red that are like mine and less. If you accidentally have the other way switched to, it'll count those and higher. That's not what we want. We want it to be like my sample statistic and less. Please note, when you have an example problem where you need to do a not equal to, there is no option for that right here. It's only less than or greater than. So if you ever have to do a not equal to where you want it to count both tails, you need to go down a little lower and select this two-sided button. When you select the two-sided button, it counts on both tails. But we don't need that this time. So I have it selected as less than. It highlights the dots, the sample statistics that are like mine and lower. There's two places where you will see the p-value given. Right up here above the vertical line, it says p-value is 0.15. Notice at the bottom of the vertical line, it actually says your observed statistic was 15 out of 50. Another place you'll see the p-value is right here. It tells you there were 15 samples out of 100 that were like yours or more extreme, which is a p-value of 0.15. I was actually pretty lucky. I got exactly the same p-value that we got when we were discussing the problem earlier with my other simulation. Again, though, if you do this simulation and you got something slightly different, that's okay. You might have 0.16 or 0.14. In fact, let me just real quickly reset this and let's try a new simulation. All right, I redid it. I did a new simulation and notice this time my p-value is 0.12, 12 samples out of the total 100. So my p-value is 0.12, which is very close to 0.15. Again, if I reset it one more time, let's just look at one more. Okay, I redid it again, and I see that I got this time a p-value of 0.12 with my new simulated distribution. Basically, if you do this simulation, you're going to get a p-value very similar to the 0.15 that I had. 0.15, 0.14, maybe 0.17, something like that. And so your overall conclusion about the null and alternative hypotheses should be the same. All right, back to the actual lecture guide. It asks us then to describe how we do it. All right, so I said that we put the sample statistic value in the count box. We selected the less than or equal to symbol to match the alternative hypothesis, and then we hit count. In general, though, what I would like you guys to always do is you're going to fill in these top 3 boxes and create your distribution. You're going to fill in the count box area and select the correct option here or the two-sided option here. And only when it looks like this, where you have your p-value displayed, you have all these red dots displayed and the p-value given, that's when you should do your screenshot and paste that into the actual answer to the problem. So instead of having to describe it in your homework solutions, you could just show me this, and it shows me what you entered in and the p-value you got, and then I'll be able to understand that you put it in there correctly, or if you had an error, I'd be able to help you with that.